All right, so number 2, the population F of foxes in the region is modeled by the function, the following. Where T is the time in months, the population R of rabbits in the same region is modeled by the function R. So you can tell that they have visibly different amplitudes, some kind of similar K values, but I have to actually factor it out. And the axis is different, all right? So here's what I'm going to do. I'm going to try to interpret each and one. So 500. So 500 is the A, and the A, when you put the absolute value around it, this is the amplitude. So that means my amplitude is 500. So the K value. All right, so I noticed that the K, that's a number in front of the T. So the equation for finding the period is 360 degrees divided by K. I'm going to plug in 15, and when I do that, I will get a period of 24. So that means that the period is 24 seconds, or is it 24 months? Let me check the units. And it's 24 months. So the cycle repeats after 24 months, which is 2 years. So it would help to write down the units. Next, we have the axis. Well, you basically have shifted up 1,000 rather than from 0. So that's what it's oscillating around. That is the average number of rabbits and, the foxes, because it says F. And so I'm going to say the axis is equal to 1,000, which is like the mean average, the average population of the foxes. So moving on, we have, we do not have a D. The D is 0, which means that there was no horizontal shift left or right. And we're going to simply start from the axis, and we'll have a basic shape like this. I always find it easier with these questions to try to approach it by breaking down all this like fancy part of the equation so that later I can try to graph it. So maybe I'm going to work on one equation and one graph at a time so that it's not kind of overwhelming, hopefully. So what I'm going to do is locate where my axis is, because that's where I'm going to start off. So I know that the amplitude value was 500, and so I am going to say, well, amplitude is 500. That will make the maximum 1,500. And then 1,000 minus 500 is 500, and so this minimum is 500. And so remember how it said that there were no shifts left or right, so I can just start off here and not think too much about it, because a sinusoidal, again, looks like that. All right, I need to pay attention to the period. So the period of this function is 24 months. That means my 5 corners are going to stretch across from here to here, where this is my first and this is my last coordinate. So halfway through, I'm going to put another coordinate there because this is the general look of a sine graph. At this point, I am going to put a coordinate at 6, 1500, following what the general sine graph looks like. And then I'm going to go to 18 because in my head, I'm doing 12 plus 24, which is 36, divided by 2, which is 18. All that wasn't necessary because of how like the grids are nicely formed and measured, but I do keep that little adding and dividing by 2 in mind, because in case I'm dealing with like decimals and it can get hard than just dealing with whole numbers, right? So we got to prepare for all of that. So what I'm simply going to do is I'm going to connect the dots and try to draw it in a curvy manner. You want to try your best to draw it curvy so that it doesn't represent like straight lines. I'm going to assume that it is going to continue like the cycle, and I'm careful not to make it reach like the max to right away. So I'm going to name this graph F at T. Okay, so let me kind of interpret what's going on. I'm noticing that this is the max right there at 6. Noticing that's the min at 18. What else? Well, that is the axis. So I'm going to do it in light blue. That is the axis occurring at 24. That is the axis or the mean value. So I'm just going to write, instead of writing axis, because that might mean like nothing to us in terms of population, we're going to say that's like the mean value, what the average population is, and also right here. So now we have this Fox's population, and you could definitely use Desmos to try to help you initially, but it is going to help if you can try to graph freehand, and it will take some time, but you will get there. And so we're just going to write that the period for this was 24. And there's our Fox's graph. Okay, so let's look at the graph R at T. So first off with the 5,000, that is the A value. And because A is equal to 5,000, that's going to help me identify the amplitude by this equation. And therefore, the amplitude is equal to 5,000. So what that represents is what is my distance from the axis to the max, let's say. All right, so difficulty with this equation is that I can't just leave it like that and assume things. I do need to pull that k out so that I do correctly identify it. So I'm going to pull the 15 out. And so I'm doing it in my head or use a calculator. 90 divided by 15, and that is equal to 6. And I'm going to leave everything else pretty much the same and leave it like that. So I already interpreted what the amplitude is. I'm going to move on to the other part, which is the k. So I'm now noticing that the k is equal to 15. And the equation for finding the period is equal to 360 divided by k. I'm going to get 50, p is equal to 360 divided by 15. Use my arrows to track my work. Period is equal to, unfortunately, not a whole number, not an integer, and I do get approximately 23.3 continued. When you're graphing, although in algebraic questions, I anticipate you to write in exact form, when you're graphing, it makes more sense when you use decimal value. So that's kind of the exception to the rule, I suppose. So we find that the 6 is there for where the d is supposed to be, but remember that the original equation has the negative in it right there. So I need to always pull and switch the sign when I do that. So what that means is instead of having positive 6, I'm going to have d is equal to negative 6. What does that mean? Well, you're going to shift left by 6. And when we're graphing sinusoidal, again, what does that mean? It is potentially like the first coordinate of the x coordinate right there. But I'm already finding that if I have a negative 6, that means like my graph is going to be like that, and it might not work to my favor. So how are you going to deal with that situation? Well, what I'm going to do is instead of, assuming this is in fact my first x coordinate, I'm going to do negative 6 plus p, which is negative 6 plus 23.3. That way I can get like a more reasonable first coordinate. So this could be my first coordinate of the cycle. So see how like I had to think about what is going on. I didn't simply memorize it. I didn't say this is my first x coordinate and that is the end. I had to, at the end of the day, look at my graph and realize that I don't have negatives. It's not within my domain. So I basically want to add the period, which was 23.3, to make sure that I am working with numbers that is within my domain. So with decimal values, it does seem like this question's a little more complicated compared to the other one. So I'm not done. I actually have the 1,000 left, which I almost didn't notice. So I'm going to use like the light blue because I've been using that. So that is going to represent my axis because C is equal to axis. And so that is equal to 10,000. So at this point, I want to kind of avoid getting my work combined with the other part. So I drew some lines so I could decipher those two quickly. So let's start off with the axis like I had for the Fox's equation. I have found the 10,000. I'm going to put the axis there. So I'm noticing that it is still a sine graph. Oh, and I totally forgot to put the sign. That would be, you would lose a mark or half a mark if you did that in your work. So I want to make sure I'm putting sine there because otherwise it doesn't really make sense. So make sure everything looks good. All right, so I'm gonna go back there for a second. That is the axis value. I need to find out what my amplitude is, and it's 5,000. And that means my graph is over there actually. So this is my max, and it's at 1,500 because the amplitude is actually 5,000. And I have to go down, I have to do 10,000 minus 5,000. So amplitude again is 5,000. So that's all the way over there. So that means my minimum in this case is 5,000. So we actually have a very different looking graph for the sine graph. So for the rabbit population. So it's a sine graph, there's no reflection. Because there's no reflection, I can simply start from here, or so you think. But then there's a shift. I remember there's a shift over here, and so I actually have to start from 17.3. That is my first x coordinate. So I just want to do a little sketch on the side of what my plan is going to be, because we're dealing with decimals and it's going to be hard to wing it the right if we don't really plan it out. So there's my sketch, and basically what you're doing, it's you're pretending all the things are really nicely coordinated. And so I've basically found out that this is going to be 17.3. So that is the first sketch of, okay, so this is my plan, right, for my rabbit population. This is the first coordinate you would have realized. And then what you're going to do is find the second part, which is not the second coordinate. You're not going to go in order like this, but sometimes it's easier to know where you're starting from, where are you going, where is my middle point, and then I'll find the other ones later. That is exactly what my plan is. So how do I do that? I'm going to do 17.3 plus the period. When I do that, I get approximately 40.6 because my period in this case is 23.3, I believe. And so there it is. Let's go right in the middle. Like I said, we are going to do, well, what do you think we're going to do? How do you take the average from if you had the minimum, you had the maximum? You're going to assume you had a 50% in French and you had 80% in math. Well, you do 50 plus 80 and then divide it by 2 and you get about 65, right? So that's the same idea, same logic. And so what you're going to do is 17.3 plus 40.6 with the lines on top and then divide by 2 and you're going to get 29.0. All right, I want to plan out my second and my fourth coordinate. Don't really have room. And these numbers indicate the order I'm kind of finding things and what usually makes more sense. If you find it another way and you're getting the same answers as me, I guess that's fine. I'm just telling you one way you can look at it. So what we're going to do is we're going to do 17.3 with the line on top. And what do you think? We're going to do the 29, right? 29.0, and I'm going to add it, and then I'm going to divide it by 2. What do I get? Well, I did this in advance, and I got about 23.2. And this is approximate. It's not a line on top because I'm just double checking and I get 23.1666 when I do it on the calculator. Keep in mind, you are assuming that there's brackets here because if you just put it in your calculator left to right, this, division sign 2, you might get the wrong answer. You got to make sure that you're doing this part first and then dividing it by 2. All right, so make sure you're getting the same answers as me and don't just follow along. So number 5, so the last coordinate I'm going to get is like the coordinate between the 3rd and the 5th. So what I'm going to do is add the 2, so 29.0 plus 40.6 with the line on top divided by 2. Brackets are there whether or not I write it or not explicitly. And when I do that, I'm getting 34.8, not exact, so I'm putting it as approximate. I'm getting 34.833333. So that's what I'm getting. But so these are the coordinates, the magical coordinates I need to try to graph it. So, I mean, it's not that bad, but you can tell that if you don't really like plan it out, it might look messy otherwise. All right, so I'm going to go back to the graph. So what do I need? 17.3. So we are at 17 over there. So maybe over there. Maybe over here is where like 17.3 is. So I'm working on this like fancy iPad. So I'm going to draw a line because that's my equivalent ruler to line it up. And then, so I can tell that the graph is going to be right over there. Okay, after that, I'm probably going to not use that ruler. There you go. So that's 17.3. I'm going to, well, oops, I can't even fit 40.6. I can't fit 34.8. I can't really fit 29.0, which means I can only fit these two. But, oh well, we'll go with that. So 23.2, that's 23. That might be approximately 23.2. I'm going to do that like little ruler trick over there. So I need to plan out where is my graph going to be. Well, look, according to my graph, I went at the axis and I went to my max. So I'm simply going to do that. Okay, it's not that simple actually. But especially if you're seeing all these decimals and overwhelming numbers, it's not really simple. It's not a really simple problem. But hopefully you get the big picture of what's going on. What I'm trying to say is you're basically going from axis to max. And I'm going to draw my fake ruler again longer. So when I do that, that means I want a coordinate right there. Perfect. So it's kind of going along. I mean, I have 2 coordinates, but it's certainly not enough. However, I could kind of go back in time, like move in increments going backwards. And so what I'm finding is that every little increment from here to here, I can simply do 23.2 minus 17.33333 on the calculator, and I'm getting this is 5.8667, which is close to 5.87. I'm going to unhighlight all these things because I feel like the 5.87 is actually the most important part here. So what's going to happen is that, well, if I go 17.3 minus this number, I'm getting 11.4. So I'm going to go back here. That's 11. That's going to be approximately 11.4. I don't want to go back and forth with the graph, so I'm going to do 11.4, 33, whatever is left on my calculator, minus the 5.87. So that's 5.56, which is approximately 5.6. So I'm going to the 5, that's 5.5, and that should be about 5.6. So that's about 5.6. And if I do that minus 5.87, I think that's when I'm in the negative, and that's like negative 0.30. I mean, it can help me kind of plan it out. All right, so all these numbers are going to help me graph it. And how I do that is that basically I'm assuming this is what the cycle would have looked like, right? But it's like at an inconvenient domain or like graph. Sometimes it's harder if they draw the graph for me in terms of the axis, because then I can't draw my graph just like this, which is a lot easier. But anyways, you got to kind of work with every situation. And so when you are planning it out, you are going to kind of like work backwards. Well, you're going to hit your minimum, and then it's going to go back to the axis, and then it's going to go start at the max. So that is my plan. And so I am going to bring my ruler and draw my coordinate so that it hits the minimum over there. And you notice it doesn't like line perfectly with the foxes, but that's okay. I'm gonna move my ruler at 5.6. So in your case, you should try to like, you know, use an actual ruler and make it work. Okay, so that's gonna go back to the axis. And then over negative 0.3, it would have actually hit the max over there. So I will temporarily put a coordinate there. I might erase it later. And now I'm going to erase my ruler. So a lot better now. You have a more full graph. And so your graph is going to look more so like, oops, like that. I'm going to erase that little dot. And that's what it looks like, interesting enough. And that is the rabbit population. So I'm going to quickly put, okay, this is the minimum. This, well, it's not really the max over there. This is the max. They almost started off at the max. This is their mean. And this is their mean, because that's where the axis is. I want to kind of continue this graph. It doesn't have to be perfect. I'll just draw it like this so that it's symmetrical. Basically, so this is your rabbit population, and this is your fox population. General observation is that these are the winter months, and these are the winter months. Okay, and we'll actually observe it over there. So let's take a look at the data, right? So for the fox, which means we're looking at this graph, so the month for max, so it reaches the max once throughout this graph, and it occurs on the number 6. We can say that it's basically the first year of June. It's better practice to further interpret what that means, because especially if you have a number like 18, it's obviously not obvious what month that is, because you have to make sure that's very explicit when you're explaining your work. Whereas, you know, with 6, you might be like, okay with just saying 6, but it's better to explain it just in case. So the max value means that I need to look at the Y value, and we notice that it's 1500. For the month for min, we're going to look at this part, and it's occurring at 18. So for 18, what does that mean? It's not the first year, but it's like the second year, June. All right, the minimum value. So when is the minimum value occurring? The minimum value is occurring on at 500. It has a Y value of 500. So the month for mean. So the month for mean is occurring at 3 spots, 1, 2, 3. It's occurring right at the 0, 12, and 24. Which basically suggests approximately like late December of each year. The mean value, well, the mean value is the axis value, and so therefore it's 1000. So let's look at the rabbit population and interpret it. So let's look for the month for max. So the max is occurring at approximately 23.2. So let's at 23.2. And the 23.2, what does that mean? Well, in your head, you might do 23.2 minus 12, and you get approximately 11.2. 11.2 puts you around November, so you can say like second year November. It's not the first year November, but it's the second year November. What is the max value? It is the max value of 10,000 plus 5,000, which make up 15,000. So month for minimum, this is occurring once right here, and it is occurring at 11.4. So we're going to put 11.4, which is approximately mid-November. And the minimum value is 5,000. Month for mean. So month for mean is right here and here. The values are occurring at 5.6 and 17.3. So what that means is you have about late May and July. Lastly, for the mean value, that is the axis value, and it's at 10,000. So there are, in general, a couple of things that we notice when we describe the relationships between the max, minimum, and mean points of the two curves in terms of the lifestyles of the rabbit and foxes and list possible causes for the relationship. So for example, I'm noticing in general, around the time that the rabbit population is its max, it's the fox's mean population. Around the time where the rabbit's population's a minimum, it is the mean population for the foxes. Lastly, around the time that it's the mean population for the rabbit, it's the max population for the foxes. There does seem to be some kind of correlation and relationship between the two, because as you notice, although the numbers are not dot on, there is some kind of pattern of how the values are hitting, so that it's either hitting the max, min, or axis, so a significant point within the sinusoidal function. So we could say relatively at rabbit's max, we said that we had the fox's mean. So at the rabbit's minimum, we notice that it is fox's mean again. Meanwhile, at the rabbit's average, we notice that it could go both ways. It could basically be the fox's minimum or maximum. And that might be because if you look at the graph carefully, it's like once the fox hits the maximum and the rabbit's population is starting to decrease, you're also noticing that it is getting colder beyond the month of June. And so things are starting to cool off and the preys are not as available. And that's why it now goes back to its average, at least for the rabbit population. And so not always, grow at an exponential rate, and what will happen is they don't have enough prey to eat from and things like that. So it seems like it is like a sinusoidal pattern based on what's going on with this particular case. Other factors, like external factors that might come to play, is maybe the temperature and the season, right? In the winter months, there is generally a low number of rabbits that is affecting the population of the foxes. So it's like there's a low population, and then as the month gets warmer, it's starting to increase. So also temperature and season may factor in. So in terms of writing it down, what I wrote is, what if the prey's population becomes so minimal that it becomes extinct? Well, how's that going to affect the fox population? Well, it must take a toll on them as well. So just writing that down, maybe there's less prey available in the winter months. So those are some of the reasons why, but I invite that you come up with other reasons as well, as answers may vary for this.